Okay, class. My name is Zongsen Innocent Ndlovu. I am a student at Stadio. I'm doing an advanced diploma in TVET and vocational teaching. Today I'm going to deliver a lesson that is found on the lesson on N6 Industrial Electronics. The lesson is found on Module 5. Today's lesson is about electrical safety devices. Electrical safety devices. Now, electrical safety devices. When we talk of electrical safety devices, we talk of what are electrical safety devices? Electrical safety devices are devices that are installed in electrical circuits that cut off the current in case of an emergency, or in case of an emergency, in case of overload, in case of leakage current. Now, electrical safety devices, they cut current in case of an emergency. Can be electrocution, overcurrent, and leakage current. Leakage current. Now, we have more than two types of electrical. We have two types of electrical devices. We have electromechanical devices. These devices use both electrical and mechanical components to perform what you call a function, such as to perform a function of cutting the circuits, such as to perform a case of cutting a circuit. Now, why are they called electromechanical? With electromechanical, because they use both electrical and mechanical operation. Now, what are the examples of this? We have the examples of relays. We have relays, and we have what you call manual switching. Second example is manual switching. These are two examples of electromechanical relays. They are mostly found in industries. We are unlikely to find them in our homes. Then we have another one, a second one, which is a second electrical device, which is known as simple electrical safety device. This one strictly uses electronic operation. Now, electrical safety devices, this one is a specific type of that is designed to protect the circuit using circuit breakers and in case of overcurrent, and by cutting the circuits using circuit breakers and GFCI. This one uses what we call a circuit breaker, or GFCI. But we're going to explain the GFCI later, and then we also have an earth leakage. Earth leakage, the circuit breaker cuts the current in case of overcurrent or electrocution, or what you call and then current in case of electrocution and overcurrent or short circuit. And then the earth leakage cuts current in case of electrocution, and it takes the leakage current to earth. The GFCI and the earth leakage are almost the same thing. Now, what are the advantages of fitting these electrical safety devices in a circuit? These safety devices, they prevent electrocution, such as they prevent electrocution and injuries such as what you call electrocution, such as falls and explosion. So because in electrical you also found explosions when there is a bridge between phases. If there is a bridge between phases and the voltage is high, you may find what you call an explosion. So these devices are help in cutting current when in case of that emergency. In that instance. Now the advantages of using another advantage in this circuit, in this, they also they help us in identifying now the electrical fault. If there's an electrical fault, it doesn't need to shock anyone or to cause an explosion or to cause an accident. They just trip and cut the electrical current flow. Now, what else are we gonna? Another thing we're gonna look at now? We're gonna name and describe what you call any two electrical circuit devices. So for this, for instance, I'm going to name the circuit breaker. I'm going to name any two. Number one is the circuit breaker. Like I explained, the circuit breaker, it cuts current in case of an emergency or electrocution. Now, and then we have what you call the residual current device, which are known as RCDs. And then we have residual current device, RCDs. Now, how do they operate? Circuit breakers, they protect against overcurrent and short circuits by cutting the current flow. Residual devices, which are known as RCDs, and earth leakages, they detect dangerous electrical leakage current and by grounding it instantly, cutting it off power to prevent electrocution. That is my topic for today. Now, where do we find these circuit breakers? We find circuit breakers in our homes, where, for an example, when you connect a fault toaster and the toaster is faulty, when you now touch the toaster and the toaster is faulty, it will electrocute you. Now that's where the safety device come in now. When you get shocked by this toaster, it is electronically connected to the circuit breaker. So the device will pick that someone is getting electrical shock, and it cut off the current flow. It will cut off the current flow to the device. Now I'm gonna make a small simple sketch. You have a circuit breaker. The circuit breaker is your DP, and you have your toaster here, and you have your toaster, and this is a live wire. This is a live, and this is a neutral going back to the neutral bar. Now, and then we have an earth wire coming from this to the earth point, to earth the toaster. Now, if the toaster is faulty, it could be that the earth conductor there's a breakage here in the earth conductor, and the device is no longer protected by the leakage. Now there's a leakage current from live to the toaster. Now when you touch the toaster, the device will choke you, will shock you, so there's electrocution. So if there's electrocution, the circuit breaker will cut off to protect the human being on the toaster. But that is how the circuit breaker works. But if now the residual circuit current breaker, which is also known as the earth leakage, also known as earth leakage. Earth leakage, it protects the device in case of a leakage current. What is leakage current? Leakage current is what I just explained to you. Now the toaster is faulty. If the toaster is faulty, the live now is touching the body of the toaster. When it is not touching, it's supposed to touch. Now meaning the toaster is now live. When you touch the toaster, you get electrocuted. Now this earth wire now takes the current down to earth, meaning it will cut the circuit breaker, it will cut the current to, I made a mistake here, this one comes here, to the earth leakage. This one comes here straight to earth leakage. Now the earth leakage will cut the circuit to the breaker, since there's a wire, the wire comes like this to the breaker. So now this is a supply. So now when toast is faulty, the earth leakage will cut